Okay, another type of op-amp circuit is op-amp integrator. As its name implies, the op-amp integrator is an operational amplifier circuit that performs the mathematical operation of integration. That is, we can cause the output to respond to changes in the input voltage over time. As the op-amp integrator produces an output voltage which is proportional to the integral of the input voltage. Suppose as we replace the resistor of feedback by capacitor, so that we can call it integrator. So in the previous, during inverting, non-inverting, summing, differentiate type of op-amp, the feedback is sort of a resistor. Now replace that resistor when by capacitor during this feedback, we can call it integrator. So how to determine V out during this circuit or during this integrator op-amp? Now, as you see, our V in through resistor enter to the inverting terminal. Also, our V out back through a capacitor to the invert terminal. So, when you see V in through this resistor to invert terminal, again through this capacitor to the output. So by applying KCL method, V in or I in equal to IF. So I in is the same with IF according KCL method or by applying KCL method. So IF is that is current of the capacitor. So that means I in equal to IC because IF replaced by IC. You know IC during charging discharging of capacitor, if you remember during fundamental course, when to determine IC becomes capacitor of dVc over dt. That d of Vc over d of dt means that's charging means of C of V. So IC becomes d of charging over d of t. That is means IC becomes d of q. That means C of dVc over dt. This is current sort of capacitor, change of voltage over change of time. Now, so this value means IC. So I in, when you first simplified, I in V in sort of this resistor enter to the inverting terminal. So V in minus V inverting over R. Then IC charging of CF d of Vc over d of dt. So d of Vc from inverting through this capacitor to the V out. So this means Vi minus V inverting over R becomes CF d Vc becomes V inverting minus of V out over dt. So as you know, the non-inverting terminal of the op-amp is grounded. So V non-inverting becomes 0 because it's grounded. The rules of op-amp circuit analyze V non-inverting equal to V inverting. This becomes 0. So replace V inverting by 0. So Vi minus V inverting when replaced by 0 over R, this becomes C of feedback capacitor d of 0 minus V out over d of t. So this means Vi over R becomes C of F d of minus V out over d of t. This becomes, when it is rearranged over R, that's equal to minus of Cf d of V out over d of t. Then now simplified dV out over dt. So this means 1 over minus Cf when you cancel, multiply by Vi over R, d of V out over d of t. This becomes 1 over R of Cf, that is negative because that's minus, over Vi of t. So when in both sides we take integration, so we can get V out. So in both sides, when you take integrate, we get V out. So V out becomes minus 1 over R feedback resistor, the integration of infinity over t Vi of t dt. So this is our V out during integration. We can get V out during integration is, it looks like this one. That's to clear, V out becomes minus 1 over R of Cf, the integration of from minus infinity to t Vi of t d of t. So now V of t becomes minus 1 over R S, that is resistor input Cf, the integration of minus infinity to sort of t Vst of dt. So integration is a process of continuous additions. So where they apply integrator, the application of integrator is ramp generator. Integrator responds to a constant voltage. This ramp generator very useful in timing circuits. What the integrator respond to? A square wave, useful for waveform generators, called a ramp generator. So that means input signal that is square wave, then the output can become sawtooth or triangular wave. So op-amp behavior on triangular wave input. Integrator is well used for voltage to frequency converters. So this is about the integrator. The next we'll see about differentiator.